today's agenda, first we're going to touch on a PC market update before Ezra dives into an AI PC update. And lastly, I want to touch on ARM-based PC chips. So Haley introduced us. This is Ben Carbonneau speaking now. I'm a senior analyst with TBR. I have Ezra and Alek Maxfield on the line as well. Ezra is a principal analyst and Alek is a research analyst, and they're both very knowledgeable about devices. So without further ado, I'll throw over to Alek.
Perfect. Yeah. So in terms of the PC market, so the story from the OEMs as well as from TBR is that we're really approaching the tail end of the demand slump that we've been in for the past several quarters, and that the market is kind of jumping into that gradual recovery. So, and if you wouldn't mind just going through thank you. So part of this is going to come from the onset of the next major PC refresh cycle, where we're going to be seeing more and more people starting to look to replace those machines that they bought during that surge in PC demand that we saw at the beginning of the pandemic. This is one place where we're going to see AI come up from a strategic perspective, where vendors are hoping to accelerate this refresh cycle with the development of AI PCs, as we're going to talk about later in the webinar. Also, vendors are reporting normalized channel inventories, which is leading to an easing in price competition. With all of that said, we're looking at early 2024 as the time frame for when we expect to see year-to-year growth in PCs start up again. So obviously, it's not going to be consistent across the board for all of the OEMs, but as a more general trend. And then, so on the go-to-market side, vendors remain really focused on driving sales of higher-priced, higher-margin premium machines. So this includes things like high-end commercial workstations, including those that are being promoted as being designed for handling AI and machine learning workloads, as well as gaming PCs on the consumer side. And then vendors are also still capitalizing on hybrid and remote work trends, promoting more portable form factors and features like higher quality webcams and AI-powered video conferencing tools for things like automatically keeping people in frame and reducing background noise. And I think that that's probably a good segue into our next segment.
Thank you. There we go. The AI PC. We're beginning to hear the first announcements that by the end of the year, by the end of next year, we will be looking at AI PCs. Intel has announced that there will be acreage on its new Meteor Lake systems on chip that are NPUs, neural processing units. We're seeing great strides with all the various implementations of large language models. And we're seeing some use of earlier AI, machine learning kinds of things on PCs. However, we think this current generation, the one coming in the next year, is not the big one. The big one is after that, and it's truly big. The upcoming PCs will be more suited for running AI tasks. They'll do the kinds of things that are being done locally on PCs using AI. This is video enhancement, audio enhancement, recognition, that kind of thing. The real potential of large language models are going to wait for another generation, and these will be radically more powerful, easier, and relevant PCs. More powerful, easier, and relevant because the underlying hardware can support them, but also primarily because the software, both the LLM software and the software the LLM can now drive, will have evolved by that time to represent a PC that can do a lot more. What we need is to achieve what we're calling distributive generative AI. So this means that while the big large language model will reside as it now resides in large computer centers in the cloud, there will be subsets of that model that will run locally. And with a language model running locally, you get improvements in privacy. You can set what parts of that model, as it learns, get propagated up to the big model in the sky. Responsiveness, the turnaround time is more like a PC and less like going to the server. And finally, cost of AI is quite high, and it has to come down before it becomes universal. Having new hardware on these new PCs will drive higher prices. They're more capable. You need more capability to get the best out of the new AI. And because new technology evolves more quickly, the refresh cycle will close up for several generations. We're expecting that the primary additional hardware will be a NPU, a neural processing unit. It's possible that other kinds of silicon will evolve, and it's possible that we'll start with an NPU and then move on further. What we're seeing is a world where the underlying computing hardware will be evolving and perhaps changing rapidly, and this will be a world where the PC won't be as stable year to year as it's been for the last couple of decades. What you're seeing with this distributed generative AI is a personal model, a model for the user in a personal ecosystem. And here I'm talking about other devices the user accesses, and that will be interacting with business models. So each business will have its own LLM that has controlled access to the big LLM, control contributions to network LLMs, and then probably even within that you will have departmental models and then individual models. A lot of inference and training activity happening on the PCs. So why do we say that this new AI PC is a big deal? Well, I started my career as a software designer, user interface designer. And when you sit down and say, what can we build? What the PC can do is just about limitless. What the user can get the PC to do depends on the user interface. If the user is a coder, they can write code and it can do just about anything, but things can take a long time. For the most part, we give users choices. We provide them with buttons and sliders and menus and things like that. Those things call out the most commonly used computer tasks and let you get to them. But there's a lot there that you could do if you had a broader interface to the capabilities of the machine. So when I looked at the kinds of tasks that the modern LLM AI can contribute to in using a PC, the list was impressive. Drafting is what we're currently talking about. So I want a document that says this or a picture looks like that. I'm being kind by saying drafting. Sometimes these drafts are expected to be and are submitted as final product, but where it's really capable is getting the user started. Research, already in the cloud, we're benefiting from the far better understanding of the kinds of questions we're asking search engines. Being able to actually ask in a sentence that qualifies things and not come up with a set of words that get you the information and don't get you a lot of information you don't want is quite a gain, and we'll see a great deal more. People will be able to gather the information they need. The next one was finding, and let's see if, thank you. Finding means finding files, appointments, emails, gathering, getting together all the documents you need to do an analysis, make a decision, create a presentation. We spend a lot of our time on PCs finding things. In fact, our tendency is to fill them up with as much stuff as we possibly can until finding has become hard. By admin, I mean arranging things, making things work. The most obvious one that everybody talks about is, arrange a meeting where these 4 people are going to be. Find me a time that can work, send out all the irrelevant emails, take the feedback, and present me. And it is, in fact, the kinds of tasks that back in another time were done by administrative assistants for most people. They're now done by administrative assistants for a small number of people. Integration. being able to combine the various processes that are available through the software on your PC. We do it all the time. We move data from emails to word processors, from spreadsheets to PowerPoint. Doing those things is laborious. I mean, we can do it. It's powerful. You can do great things this way. But being able to simply ask the computer to do this analysis, take the graph and embed it, and let me see what you got. That's going to be a big help. Automation means that when you have a process, you're going to be able to repeat it fairly easily and create all kinds of capable and flexible scripts for the things you do with your PC. Configuration is all that stuff that's involved with setting the right screens and resolutions and input and output devices and all that. It's a pain and hard to find, but with a interface that you can talk to and say, you didn't get quite right, let me try something else, those sorts of things will become a lot easier. And then you can train yourself. You can learn new things. You can learn how to do new things. I wasn't talking about model training or anything else like that. And finally, you can code. I mean, it might be in one of the common coding languages now. It might be in new scripting languages. But all the things that make the step up to coding intimidating and somewhat unproductive because of the limitations of coding will be much ameliorated by these new PCs. So what are the industry implications of empowering a PC with all the capabilities of a local large language model? So the first thing I said, this year's and next year's AI PCs will be nice, but once we get the whole thing together, it's going to be amazing. We need the distributed Gen AI, and we're getting there. There's lots of models running on PCs, models of new systems to subset LLMs. A lot of research in smaller and more local PCs and their relationship to other smaller and more local large language models in relationship to other models. We need to have that settled down. And of course, Microsoft will lead with a platform standard. Software designers need to know what kind of hardware is available. And Microsoft is the company that tells them what hardware is available and will provide its own set of capabilities that the LLM can access. I mean, it already has them in its object model, but they will be developed further with an eye to what the LLM will be doing with it. And you can do anything in the Microsoft world with their object model. This standard, when Microsoft sets the standard, will come with higher prices and faster refreshes for the PCs. So now you have a standard platform that has more and more capable hardware, and hardware that's going to evolve faster. And at that point, you'll see the pickup in the AI PC market. Now, when we think about this, the ability to talk with your model and ask for anything and get anything is quite impressive. But, the chat is the user interface of last resort. We don't mind having a discussion about an extensive analysis or a piece of administration. We would mind having to have a chat to move windows, change column widths, or boldface something. So you still need to build an a UI, And when we talk about automation, the point of automation is to be able to just grab the thing off the virtual shelf and use it, not to discuss which one you want to use and have another opinion. And Microsoft, again, will lead here. It's just in the place where it is building the platform on which other people can build. And there's still many, many opportunities, because now you can conceive of applications in our traditional sense of something that has an interface that we can interact with that does a task, that applications that don't come with a standard package. And that will lead, of course, to acquisition fever as companies with money will be buying companies with attractive products. Microsoft is one of them, but by no means the only one. And that, I think, concludes my part of the discussion. I will hand it back over to Ben, who's going to talk about ARM chips for PCs. Are we having a technical problem? Should I try to pick up on this?
Oh, sorry. Can you hear me now?
Now I can hear you, yes.
All right. So thank you, Ezra. As most of you know, the PCs today are primarily powered by x86 chips and not by ARM chips. However, x86 chips use more power than ARM chips. And this is why we've seen ARM chips at the heart of smartphones for over a decade now. And some of those chips in smartphones include Qualcomm's Snapdragon series, famously Apple's A series of chips, and Samsung's Hummingbird, which was rebranded as their Xenos series of chips. However, ARM has made entrances into PCs as well, but there's been much weaker adoption around that until really in 2020 when Apple released its M series of chips. So just looking at this list here, you see that Microsoft, they did have these SQ chips, which were developed jointly with Qualcomm, but really these chips were just Qualcomm's smartphone system on a chip with some minor tweaks requested by Microsoft. So they were releasing these chips in their Surfaces, but they never had the performance of anything close to an Apple M series chip. Really, it was kind of more of a branding move by Microsoft. I think with the SQ line, really, it wasn't that much of a differentiator. And over the years, there had been releases of other laptops from the general PC OEMs, the Windows PC OEMs, leveraging Snapdragon chips. So Microsoft, I think, was trying to differentiate itself a little bit with this SQ nomenclature, but really it was kind of a branding move that has fallen a little bit flat. However, again, Apple's M series chips are very legitimate, they're powerful, and they extend battery life, and they have led to the company being able to phase out its reliance on Intel for Mac chips. So why is this an important subject now? As we know, AI workloads are really power intensive. So this is kind of the bridge between Ezra's AI PC topic and ARM-based PC chips. As we see more AI workloads, kind of Ezra alluded to, move to the endpoint on the PC, that's going to require a lot of power. And if we want these done on a mobile device like a notebook, then we're going to need more power efficiency. Secondly, this topic's really important now because we could finally be seeing an ARM PC chip for Windows that does compete with the Apple M series chip coming out sometime next year. And I'll talk a little bit more on that later. And the third reason really is, and you could debate that this definitely has to do with Apple's limited commercial presence and everything that happened throughout the pandemic with the PC market dynamics, but Apple has seen a significant uptick in PC market share since its release of M series powered MacBooks. So, there's the M3. All right, so moving on, Microsoft has a really big role in the adoption of ARM-based PC chips for Windows, right? Microsoft owns the Windows operating system, and clearly what gave Apple the leg up in transitioning to its M series chips from Intel and AMD chips was that the company owned the hardware, they owned the operating system, they also owned their app store, right? As well as they had experience creating those A series chips for their smartphones for decades, right? So the limiting role for adoption of ARM chips for Windows has really been compatibility issues. And that's because ARM leverages a different instruction set than x86 chips. So again, I said earlier that most PCs are powered by x86, which can read and understand programs written with a x64, x86 instruction set, whereas ARM chips really rely on ARM64 instruction set. And that is one of the things I'll delve into in a moment here. So in 2012, this is an important milestone for Microsoft here with Windows RT. I honestly wasn't super familiar with Windows RT until I started researching it, but it was the company's mobile operating system. If you remember, back in 2012, Microsoft was pretty big on really tablets were big. They were going to take over. They were going to replace PCs. Obviously, that didn't happen, and Microsoft Windows RT kind of flopped as it was the mobile operating system. It powered the Surface RT, which leveraged an ARM-based device, but with not enough apps on the Windows Store, it failed to see major adoption, and it was really a flop by Microsoft. But the importance of this was it was Microsoft's foray into ARM on PCs. Even though it was really a tablet then, it was them kind of thinking more in the kind of putting an ARM chip on a PC. So fast forward 5 years and Windows 10 is released. So Windows 10 included something called x86 emulation. And what that did was it allows that x86 instruction set at the heart of these x86 applications to be compiled into an ARM64 instruction set and run on an ARM-powered chip. So whatever Surface was released in 2017 with the ARM chip, probably from Qualcomm at that time, could run x86 applications. However, it would run them through an emulation layer, which would make them run slower than if they were running natively on x86. And over the next few years, between 2017 and the launch of Windows 11, Microsoft continued to release Surface devices powered by Qualcomm mobile SoCs. Of course, in 2020, it moved to its SQ series, which again was really just, a Qualcomm mobile SoC. So the important thing here with Windows release in 2021 was that it allowed for x64 emulation, which is similar to its x86 emulation that came with Windows 10. However, if we think about legacy Windows applications, they're written mostly in x64. So now there was that emulation layer to allow for ARM-based PCs to run these x64 applications. Again, they were running slower than if they were running natively. It also introduced with Windows 11 was ARM64 emulation compatible, and this guaranteed interoperability between x64 instruction sets and ARM64 EC. So really what that did, it was Microsoft trying to make it more appealing for developers to move certain CPU-intensive workloads into ARM64 EC to reduce, to improve performance and reduce strain on the CPU. Lastly, in 2021, when Microsoft Windows 11, ARM64X came out, and ARM64X, again, it really allowed more of that it kind of helped push the developers more toward ARM from that x86 or x64 instruction set. The next move, and this is probably the most, it's the biggest move that Microsoft made toward getting its developers onto ARM, was Project Volterra, which was the Windows Dev Kit in 2023. And this is a device that's ARM-based, and as we mentioned, this device has an NPU, so that neural processing unit, and it allows for the development, debugging, and testing of ARM native Windows applications. So really, this is Microsoft's push to further getting developers to write ARM native applications that run on the ARM native system. And as we go forward, we'll see DevKit 2024 include more of this kind of ARM support. In 2022, also there's ARM64 native Visual Studios introduced. Again, that's just trying to get these developers, these Windows application developers over to ARM. So recent developments, and let me just click through these. Microsoft SQ3 processor, again, that's still kind of that beefed up Qualcomm SoC, so really not a dedicated PC, not a purpose-built PC ARM chip has come out recently. The Apple M3 chip slated to release, and that will be a very powerful PC purpose-built ARM SoC. But circling back to what I mentioned earlier with us potentially seeing a Windows-based ARM PC chip coming to market that competes with Apple's M series, that's the Qualcomm Snapdragon X. And if we just look into some history behind Qualcomm's mobile SoCs, so why has Qualcomm not been able to, in the past, make an SoC that rivaled Apple's M series? It's really because Apple had so long to develop that M series chip, right? If we think back in history, I think in 2010, Apple was on its A4 chip in its iPhones. 10 years later, in 2020, was finally when that M1 series chip was released. So they had quite a lot of time between when they started working on their ARM-based SoCs for smartphones before they released one that would be, rival Intel's power and be good enough for a Mac. Additionally, in 2021, Qualcomm acquired a company called Nuvia, which is a chip design company, and it consisted of ex-Apple engineers who worked on the A-series chip. So it's reasonable to think that those Nuvia engineers were really key in the development of this Qualcomm Snapdragon X, which is a purpose-built PC ARM-based SoC. Lastly, for recent developments, we know that AMD and NVIDIA earlier this year reportedly developing their own ARM-based PC CPUs, trying to get into that market. I think NVIDIA's been working on this for a while, but it's really just become apparent in public that that is going on. AMD, of course, following NVIDIA's lead and trying to do the same there. There's also rumors that Samsung is doing the same. So to wrap that up, I really think what we'll see is as these AI workloads move to the edge, to the endpoint, I should say, they're going to need PCs that are able to run these workloads without consuming as much power. And I think that really is where the ARM-based PC chip value proposition is. So with that, I would open it up to a Q&A, and this can be on any subject. Please just leave your question in the Q&A box, and either Ezra, Alek, or I will try to field it. And I don't know, Ezra, if you had anything to add from your own thoughts on ARM-based PC chips.
Well, I'm not sure if you made clear. I'm willing to bet that Microsoft's going to have its own ARM-based PC chip probably in 2024 with its own version of Windows. The ramp up for ARM is going to be very, very slow because backwards compatibility is enormously important. But being able to do what it's always envied Apple doing, which is designing the whole system from hardware up through software, is something that Microsoft can't resist. And of course, it's already producing a large number of specialized, often ARM-based chips at this point.
All right, so it looks like we have a question. I'll read question 4. Where is Intel in the ARM-based AI PC story? So really, I think this the ARM-based PC is something that will ultimately take away share from Intel. If we look at the reason why Apple kind of moved to create their own M-series chip, it was to reduce their reliance on Intel. And I think that's exactly what we're going to see from these other PC OEMs as more ARM-based chips come out. So the reason why these x86 chips were coming from Intel and AMD primarily is because Intel created x86 way back in the day, and then had to license that to AMD so that IBM would allow Intel to be the supplier for their first personal computer. That's why we've seen Intel and AMD have these x86 chips. Intel's x86 business is massive, so it's gonna be a slow move toward ARM. I think ultimately ARM will take over, but this is not something that's happening within the next 5 years or even in the next decade. So any opinions of risk-based chips on PC? So ARM is risk-based. ARM is actually an acronym for Advanced Risk Machine. So it's kind of what we're talking about here. Another question.
What we're looking at here is business motivation. The company that can create the version of Windows that runs best on any particular ARM chip or a RISC-V chip or anything else, or an x86 chip, is Microsoft. When Microsoft has a horse in that race, it's going to have an inside track on specifying the chip. Other chips will run with the software they build or with emulators, but I see no reason for Microsoft to particularly want to support competitors' chips.
Great. All right. Next question. Do you have any perspectives on how Snapdragon X or AMD's or NVIDIA's PC purpose-built chips will work well with Windows in its current form versus Project Patera? So really, I think it'll work fine with these Windows PCs, except again, when most of the Windows applications are written for an x86 instruction set, they're going to have to run through that emulation layer to be able to run on an ARM machine. And since they aren't running natively, that will decrease the performance. So currently, I don't think, I'm not rushing out to get the first computer with a Snapdragon X in it when they come out in the middle of next year. But I think as Windows gets its developers more into creating ARM native applications, then I think the value will be there. And the last question I see right now is, what evidence have you seen of AMD or Samsung developing ARM CPUs? So first, I want to say back in October, I saw I believe it was an article from Routers, and this talked about at a reliable sources, two people familiar with the matter told Routers kind of thing, that both NVIDIA and AMD were working on these chips. And the Samsung, again, that's just a rumor on Samsung. I know that AMD and NVIDIA are doing this if we're to believe these router sources. But for Samsung, it just seems like the logical thing to do for them. Their PC business is still pretty small, but their foundry business, I want to say it's growing, and they do have that kind of legacy of creating their own ARM-based chips for their Galaxy smartphones. So I think logically it would make sense that they would eventually start to build out their own ARM-based PC chips. However, I think they're definitely behind Qualcomm currently in the race there. And just resource-wise, I would expect NVIDIA probably AMD to come out with those chips before Samsung comes out with theirs, if they are indeed actually working on that.